Okay, this is video number 4 for chapter 4. I'm going to demonstrate using Cramer's rule to solve a system of 3 equations in 3 variables. First, we need to find the determinant of the coefficient. We call this a coefficient matrix. Here's our 3 equations, 3 variables, x, y, and z. This is the coefficient matrix. And what I've done is I've went down this bottom row, because you can use any row or any column. Remember the sign array, because that determines what happens to these values when you put them in front of these minors. This is called expansion by minors. So this, starting here, it stays what it is. And these 4 numbers in here are the ones that are not in the same row or column as this 2. So it's 1, 1, negative 1, negative 1. Likewise, this becomes a negative 2, and it's 1, 1, 1, negative 1. This remains negative 1, and again it's 1, 1, 1, negative 1. Which gives us, down here, I'll let you take a look at this row. See where each of those things came from. And then negative 1 plus 1 is 0. Negative 1 minus 1 is negative 2. Also negative 1 minus 1, negative 2. So we end up with negative 2 times negative 2 is positive 4. Negative 1 times negative 2, which is positive 2. Add them together, you get 6. So that's the determinant. I'm going to put that over here. Now I'm going to change the matrix. And I'm going to solve for x. When you do that, the x coefficients in this column are replaced with the constant terms. So we bring the 4 and the 2 and the 2. And this time I'm going to go down this column, because those are the larger numbers. You can, any row, any column, I'm picking that one because I want the largest numbers on the outside of the minors, expansion of minors. So that gives me a 4, and it remains a positive. What's left is these 4 here, negative 1, 2, and negative 1, minus 2 times 1, 1, 2, negative 1, plus 2 times 1, 1, negative 1, negative 1. So this becomes 4 times 1 plus 2 minus 2 times negative 1 minus 2 plus 2 times negative 1 minus negative 1 is 1, is negative 1 plus 1 is 0. So we'll only have to deal with this. This is 4 times 3 minus 2 times negative 3. So that's 12 plus 6, 18. And if we're solving for x, we end up with x will equal, this is d sub x, over d. So we end up with 18 over 6, or a value for x of 3. Now we're going to solve for y. When you solve for y, what you're going to do is you're going to replace the y coefficients with the constant terms and leave the other coefficients the same. So this column remains the same, and these coefficients are replaced with the constants. This time we're going to go down the middle. So whatever's in this position takes on the opposite. So we end up with negative 4 and nothing in this column or this row. So 1, negative 1, 2, negative 1. This remains the same, so plus 2. Wanted to learn algebra, right?
Have a good night. I know how much it helps to prepare.
Yeah, well, actually these are going on YouTube so the kids can watch them while I'm on vacation.
Very good.
So we come down to this spot. The 4 items in here are the ones that are not in this row or this column. So we get a 1, a 1, a 2, and a negative 1. Moving down this position takes the negative. Can't be in this row or this column, so it's 1, 1, 1, negative 1. So we get negative 4 times negative 1 minus negative 2, so that's negative 1 plus 2, plus 2 times negative 1 minus 2, minus 2 times negative 1 minus 1. So negative 4 times 1 plus 2 times negative 3 minus 2 times negative 2 gives us negative 4 minus 6 plus 4. So that is a negative 6. And y is d sub y, which we found, over d, which was 6. We get a value of negative 1 for y. So far we've got a value of 3 for x and negative 1 for y. And we could stop there and just plug those in. 3, negative 1 plus z equals 4, and solve for z. And that would be z would equal 2. Thank you. The only thing left is the last section that we would look at, and that is the application section, where you have to translate the word problems into equations and then use one of the methods to solve that system of equations, whether it's a system of 2 equations and 2 variables or 3 equations and 3 variables. There was a video that was done in December that demonstrates that, so you can go back and pull that up. It's still on YouTube on this same channel. Stay tuned, there's more. Chapter 5 coming up after a brief intermission. Bye.